Hey guys, I am going to show you how to use the X method to factor a quadratic function. Before I do, just some quick reminders. We have a quadratic function right here in standard form. A, B, and C are going to be our coefficients and then our constant at the end. And what we have to do with our X is multiply coefficients a times c, put that in the top of the box or of the x, put our b coefficient at the bottom, and then we have to look for two factors that are going to multiply to give us the top number and add to give us the bottom number. And we use this to go from standard form to factor form. So this was the example that was given in the pear deck. I'm going to go ahead and put in an invisible coefficient of 1, which is going to be our A value. 5 is going to be our B value, and 6 is going to be our C value. So I'm going to go ahead and draw my X. At the top is always going to be A times C. In this case, it's going to be 1 times 6, or just 6. We're going to put that big right there. And then my B value goes in the bottom. My B value is 5. All right? So what I need to do is I need to find factors of 6 that are going to multiply together to give me 6, but then also add to give me 5. So I'm going to do this over here. So let's see. Factors of 6. Okay, and because that's my top number. So I can do 1 times 6. I can do 6 times 1. 2 times 3, or 3 times 2. I will tell you, because all of these numbers are positive, I actually don't really need to have 2 sets of these. I can just have 1 times 6 and then 3 times 2. So I know that all of those are going to multiply to give me 6, right? Which is half of the battle. However, now I also need to check addition. So are these factors going to now add to give me the bottom number? So that's what we need to figure out. All right, well, let's see. 1 plus 6 equals 7, not 5, right? Remember, we want it to equal 5. So that's not going to work. That set of factors is not going to work. 2 plus 3, however, does equal 5. Bam. So 2 times 3 is going to give me this top number 6. 2 plus 3 is going to give me the bottom number 5. Notice these are both positive. So what I'm going to do, actually I'll do this in red. I'm going to plop this plus 2, positive 2, and positive 3 on the different sides of the x's. Okay? I'm kind of running out of room. We'll make this work. Factor form, like always, we know that we have 2 sets of parentheses, right? That's what we were doing all of last week. We have 2 binomials, right? Which means 2 sets of parentheses that each have 2 terms in them. Fun fact, because it's a long story, but because we only have, A is always going to be 1 in this case, how I'm going to set these parentheses up is just put an X and an X in both of them. And then what I'm going to do is I'm going to drop these factors in. So remember, it's kind of important that I put that positive 2, because I'm going to drop that into the first set of parentheses, which gives me X plus 2. Going to do the same thing here, plus 3. All right, and then I can add my Y equals, and this is my answer. So what I've essentially done is I have turned Y equals X squared plus 5X plus 6. This was standard form, right? Well, because I used my X method, I've switched it to Y equals X plus 2 times X plus 3, which is now factored form. All right? I'm not going to do the whole thing now, but if I wanted to, I could use the box method to check my work, right? I could do x plus 2. Actually, I'll do it. X plus 3. When I multiply all of these out, and then put them in order like we did before last week, 2x, and combine like terms, bam, I ended up with what I started with. So now you guys can see how kind of it all fits together.